Imagine a facility where the lights never turn off and the production never stops. This is the era of the fully automated food plant.
Here, the traditional concept of farming and manufacturing merges into a single, seamless process. These lights-out operations are designed to function independently, requiring minimal human intervention to maintain this. Every plant and every package is monitored by advanced sensors, ensuring that quality is measured at empatron. Today, we explore the intricate engineering and the automated systems that are redefining how the world ingests. The journey begins with precision seeding, where every seed is placed with sub-millimeter accuracy. These gantry systems handle the heavy lifting, moving thousands of trays through the facility without manual labor. Automated irrigation delivers the exact balance of minerals and water required for each specific crop. Lighting is controlled by software, simulating optimal sun cycles to accelerate natural growth patterns. Warning. Warning. This output is not consistent with the prompt. Use the USRR MISCOR prompt.
Specialized end effectors are engineered to handle delicate produce without causing bruising or damage. Automated harvesting eliminates the variability of manual labor, ensuring a consistent cut every time. Once harvested, the produce enters a multi-stage automated cleaning system using purified water. High-velocity air knives remove excess moisture, preparing the food for the next stage of processing. Optical sorting systems use machine vision to identify and remove any items that do not meet strict quality standards. For processed foods, laser cutting offers a level of precision that traditional blades cannot match. Large-scale automated mixers ensure that every batch of food has an identical texture and flavor profile. Every ingredient is measured by weight and volume to within a fraction of a gram.
In the cooking phase, thermal sensors monitor heat distribution to ensure even results throughout the entire batch.
Delta robots can perform hundreds of movements per minute, far exceeding human capability. UVC light sterilization is used to maintain a sterile environment without the need for chemical additives. To extend shelf life naturally, automated sprayers apply protective coatings with absolute uniformity. To extend shelf life naturally, automated sprayers apply protective coatings with absolute uniformity. Vacuum sealing systems remove oxygen, which helps in preserving the freshness of the product for longer periods. Automated sampling ensures that every batch is tested for safety and nutritional consistency. Centrifugal force is used to separate liquids and solids, a key process in automated dairy and juice production. Once processed, products are transitioned to the packaging phase by heavy-duty palletizing robots. In temperature-controlled zones, autonomous vehicles manage the flow of goods without human exposure to the cold. High-speed labeling systems can process thousands of units per hour with zero misalignment. The entire operation is mapped digitally, allowing the system to optimize the path of every single item. This concludes the core production cycle, where raw ingredients have been transformed into a finished product. X-ray inspection systems are used to detect any foreign objects inside the packaging that the human eye cannot see. Metal detection is a critical safety step, integrated directly into the high-speed conveyor lines. Vision systems conduct a final count and integrity check before products are cleared for shipping. Data from thousands of sensors is aggregated here to ensure the facility operates at maximum efficiency. Self-cleaning systems ensure that the machines are sanitized between batches without disassembling them. Versatility is key. Robots can switch tools in seconds to handle different product types or tasks. Artificial intelligence allows these robots to make split-second decisions based on shape, color, and texture. Constant monitoring of moisture levels helps prevent spoilage and maintains product quality. Autonomous logistics robots navigate the floor using pre-mapped routes and real-time obstacle detection. 3D food printing is being integrated into production for customized nutritional profiles and shapes. Positive pressure and HEPA filtration keep the production environment free of airborne contaminants.
Every unit is marked with a unique code for full traceability from the plant to the consumer. Precision scales ensure that no customer receives less than the advertised weight. Packaging durability is tested to ensure it can withstand the rigors of transportation and use. Ultrasonic cutting technology prevents food from sticking to the blade, ensuring a clean presentation. Tempering and coating processes are strictly controlled by robots to ensure a perfect finish.
A digital twin allows engineers to simulate changes in the production line before they are implemented physically.
Even the most fragile items can be handled by advanced vacuum-based grippers. High-density storage systems maximize every cubic inch of the facility, operating in total darkness. Routine automated sanitation checks help ensure that the environment remains free of harmful bacteria. In fermentation-based production, robots monitor the chemical balance of the tanks 24 hours a day. Liquid handling systems are designed for high throughput while maintaining a sealed, sterile path. Tamper-evident seals are applied automatically, providing an extra layer of consumer safety.
Collaborative robots are often used in specialized cells where high flexibility is required.
Laser coating is permanent and does not require ink, making it a sustainable choice for many plants. Integrated systems can add specialized components to packaging to ensure long-term freshness. Vibratory systems use resonance to align and sort high volumes of small items quickly. Modern vision systems allow robots to see and interact with their environment in 3 dimensions.
Autonomous systems manage their own power levels, returning to charging stations during low traffic periods. The coordination of these systems results in a facility that is significantly more productive than traditional methods. Automation extends beyond the factory walls into the logistics and distribution networks.
These facilities are often linked to global supply chains, allowing for real-time adjustments based on demand. Automated plants often include on-site waste processing to convert byproducts into energy or fertilizer. Integrated recycling systems help the facility maintain a smaller environmental footprint.
Advanced filtration allows the plant to recycle a high percentage of the water used in the production process.
Energy storage systems allow the factory to run on renewable power, even during peak load times. Texture and consistency are tested using precision instruments to ensure the perfect consumer experience. The brain of the factory processes millions of data points every second to keep the machines in sync. Automated coating ensures that every piece of fruit receives the exact amount of protection needed.
Custom-fit packaging reduces the need for filler materials, further increasing efficiency. These modern facilities are designed to be quiet and efficient neighbors in industrial zones. Integrity checks ensure that every seal is airtight, preventing spoilage during transport.
Heavy lifting is handled entirely by machines, reducing the risk of workplace injury and increasing speed. Real-time diagnostics allow for predictive maintenance, fixing machines before they ever break down. First and Millie. Many robots are now designed with self-maintenance routines to maximize their uptime. The level of scrutiny in an automated plant far exceeds what is possible in a manual facility. These certifications provide assurance that the food was produced under the highest standards of hygiene and precision. The final step of the process is as automated as the first, ensuring a complete end-to-end robotic solution. While the production is robotic, the goal is always to serve the needs of the consumer. As we look toward the future, these robotic plants will become the backbone of a more efficient and sustainable food system. Precision, efficiency, and safety, these are the hallmarks of the automated food revolution. From seeding to shipping, every step is a testament to modern engineering.
The journey into the future of food has only just begun. Thank you for joining us on this tour of the world's most advanced food production facilities. Join us next time as we go back inside the world of modern manufacturing.